Good morning, dear students. Last class, I have finished all types of problems from coordinate system in a plane. I have finished different types of problems on distance formula and different types of problems on section formula. At the same time, I have finished different types of problems on center of triangle and area of triangle also. Like that, I have finished different kinds of problems in a coordinate system of a plane. But today, we'll discuss about a new concept that is the slope of the line segments. How we are going to finding the slope of line segments if it making an angles along the x-axis in the positive directions at a time, how we are going to finding the slopes of line segments, and if a line segment joining of the 2 points, then how to find out the slope of the line segments. At the same time, what are the main conditions for the slopes of coordinate axis and slopes of lines which are parallel to coordinate axis. At the same time, the conditions for to show the given 3 points are collinear with help of slope conditions. About all this today we'll discuss now. First, let us will discuss about slope of line segments. Slope of the line segment first. Slope of the line segments. Slope of the line segments. Line segments. Slope of line segment generally it can be taken as like this. First, we are taking one line segments from coordinate axis, y-axis, and here x-axis. The point of intersection of x-axis and y-axis is called the origin. Otherwise, you can increase send and you can increase extend line x-axis also here like this. X-axis. Point of intersection of x and y-axis is called the origin here. Take one line segment here. It makes in positive direction theta. With the help of this diagram, we can give definition for slope of line segment is. The slope of line segment is if an angle made by the line segments along the x-axis in positive direction, then slope of line segment is defined and denoted by m is equal to tan theta. It is the slope of line segment definition. Definition is an angle made by line segments along the x-axis in a positive direction. In a positive direction means anti-clockwise direction. In anti-clockwise direction, then the slope of line segment is denoted and defined by or defined and denoted by m is equal to tan theta. This definition for slope of line segment is if an angle made by line segments made by the line segments made by the line segments along the x-axis in positive direction in positive direction or in bracket anti-clockwise direction, anti-clockwise direction, positive direction or anti-clockwise direction, then then the slope of the line segments, the slope of the line segments slope of line segment is defined and denoted by, is defined and denoted by, is defined and denoted by m is equal to tan theta. M is equal to tan theta. It is the formula to find the slope of the line segment here. Any angle, if it is in the clockwise means the slope of value is negative value. If it is in positive direction means m is equal to plus tan theta. If it is in the clockwise direction, then we can take value for m is minus tan theta. Like that here we are taking a slope of the line segment. That's why whenever angles are given means we have to apply this formula to find the slope of the line segments. That's what here we can give definition for slope of line segment is, if an angle made by the line segment along the x-axis in positive direction, then the slope of line segment is defined and denoted by m is equal to tan theta. This is the slope of the line segment definition. If it is in clockwise direction, then m is equal to minus tan theta. Example is, find the slope of line segment if an angle 45 degree made by the line segment along the x-axis in positive direction. If they can ask the question, they gave in that question angle is theta is equal to 45 degree. 45 degree means we must and should consider theta is equal to 45 degree here. The slope of line segment is m is equal to tan theta. That is m is equal to tan theta means here tan 45 degree. Therefore, m is equal to tan 45 degree is 1. Therefore, 1 is the slope of the line segments. Slope value means it is always one real number. Slope means it should be always one real number. Like that we are finding the slope of the line segment here. Next, I will tell you some important notes, some important points under the note of slope concept. With help of the slope concept, we are going to giving some important points here. And what is the slope of x-axis? What is the slope of y-axis? What we can write slope of any line parallel to x-axis, slope of any line parallel to y-axis. Like that here we are going to giving some different types of conditions under the slope concept here. Now let us we are going to discussing about some important conditions under the slope concepts. Note yours. First important points notes. First is slope of x-axis is always 0. Slope of x-axis. Slope of x-axis is always 0. That is m is equal to 0. m is equal to 0. Because an angle made by the x-axis is always 0 degree here. An angle made by the x-axis is always 0 degree. If it is always 0 degree means we can give here m is equal to 0. M is theta is equal to m. Proof for that one is, solution for that one is, theta is equal to 0 degree always, because the angle made by x-axis is always 0 degree here. Here, angle on x-axis by the line in the first direction. Here, always theta is equal to 0 degree. When 0 degree means m is equal to tan theta. M is equal to tan theta means here m is equal to tan 0 degree. Tan 0 degree here. Therefore, m is equal to tan 0 is the 0. Therefore, slope of x-axis is always 0 degree. Slope of x-axis is always 0 degree. Next, let us discuss about the slope of y-axis. Slope of y-axis. Slope of y-axis. Slope of y-axis is always undefined. Is always undefined. Undefined. See, an angle made by y-axis always 90 degree. Angle made by y-axis. Here is y-axis and here x-axis. Or here 90 always 90 degree here, because an angle made by this line segment, an angle made by this y-axis in positive direction is always 90 degree. 90 degree means m is equal to tan 90. Tan 90 degree is always undefined. Undefined means infinity. That's what here. In this case, we can give solution for this point is, here in this case theta is equal to 90 degree here, because made by the line and y-axis always 90 degree, but made by line x-axis and the line is theta degree. Here is equal to 0 degree. But in this case we are getting 90 degree means just we have to apply slope formula here. M is equal to tan 90. M is equal to tan 90 means here m is equal to here tan 90 value is infinity, or we can call it as undefined. That's why slope of x-axis is always undefined. Slope of x-axis is always 0. Slope of y-axis is always undefined. Now we are going to take lines. Whenever they are parallel to x-axis, how are their slopes? Whenever they are parallel to y-axis, how are their slopes? About that, about those conditions now we'll discuss. Third conditions. Slope of any line parallel to x-axis. Slope of any line parallel to x-axis, is always equal to 0. Is always equal to 0 here. Slope of any line parallel to x-axis. See here, if you can take diagrammatically, I am showing how we are getting 0 here, y-axis here, and here x-axis. Otherwise, you can mention y dash also. We mention like that. At the same time, XO X dash is this. XO X dash. Take some parallel lines and which are all they are all parallel to x axis. It is one line. It is another line. Like this, we can take lines here. The angle made by all these lines is 0 degree. See here. Here all 0 degree, 0 degree, 0 degree, 0, 0. That's why 0 degree, 0 degree, 0 degree means m is equal to tan 0. M is equal to tan 0 means 0 only. That's why we have got theta is equal to m is equal to 0 only here. Take some pair of lines. Angle made by this line also 0 degree. Angle made by this line also degree. And this line also degree. Like that, if we can take any line parallel to x axis, the angle made by that line is always 0 degree. Is always 0 degree means we can take theta is equal to 0 degree here. That's what we can apply formula here. M is equal to tan theta. M is equal to tan theta means here M is equal to tan 0 degree. Tan 0 means 0. That's what we can tell here. Slope of any line parallel to x axis is always 0 only. We can take any line parallel to. In that case, slope of that line is always 0. M is equal to 0. Here also M is equal to 0. And M is equal to 0. Like that, if we can take any line parallel to x axis, slope of that line is always equal to 0 only. Now let us discuss about the slope of when parallel to y axis. How are their slopes? About that now we will discuss. Slope of any line. Slope of any line. Slope of any line parallel to y axis. Parallel to y axis is always slope of any line parallel to y axis is always undefined. Undefined means infinity. Like this. See a diagrammatically I am showing here. It is the y axis y dash this, and is the x dash. Take some parallel lines y axis. These are all lines perpendicular to x axis and parallel to y axis. Whenever perpendicular to x axis means the angle made by those lines are 90 degree only. And by this line 90 degree, here 90 degree, here also 90 degree, 90, 90, 90. When theta is equal to 90 degree, definitely we can tell m is equal to 90. That's what theta is equal to 90 means here. Here theta is equal to 90 means then definitely m is equal to tan 90. Tan 90 degree means here m is equal to undefined here. That's what we can tell. Slope of any line parallel to y axis is always undefined. Based on these two conditions, we can give one important conditions here. When slopes are equal, lines are parallel. Or lines are parallel, definitely then slopes are equal. Based on this condition here. See here, all the lines are parallel to each other in this case. But in this case, their slopes are equal. Here also lines are parallel to each other. Here also m is equal to infinity. And here also m is equal to infinity. And here is equal to m is equal to infinity. And here also m is equal to infinity. And point of intersection of x and y axis is 0 here. That's why lines are parallel means definitely their slopes are equal. If the slopes are equal means definitely we can tell about those lines they are parallel to each other. Based on these two conditions have given now, these two conditions are parallel. These two conditions are parallels with respect to slopes. That's why with help of these two we can give one condition: slopes are equal, then lines are parallel. If lines are parallel, then slopes are equal. That's what we can give one condition here: slopes are equal if and only if lines are parallel. Like that we can give one important condition here with help of these two. That is next. Fifth condition is slopes of lines are equal. Slopes of lines are equal if and only if, like this, if and only if symbol. It is the if and only if lines are parallel. Lines are parallel. Slopes of lines are equal. Slopes of lines are equal if and only if lines are parallel. If slopes are equal, then lines are parallel. If lines are parallel, then slopes are equal. Like that, we are giving condition here. If and only if condition means if slopes are equal, then lines are parallel. If lines are parallel, then slopes are equal. Right to left, what happens? Right to left, what happens? Left to right also same thing. If lines are parallel, then slopes are equal. If slopes are equal, lines are parallel. Like that. Simply, we can take if slopes are equal, then the lines are must and should parallel. That condition you must and should remember. It is the condition for parallel lines. The condition for parallel lines is then the slopes of lines are equal. That is, we can write the condition also. That is the condition for the parallel lines. The condition for the parallel lines. The condition for the parallel lines is slopes of lines are equal. Slopes of lines are equal. This is the condition for parallel lines. Similarly, in the same way, what is the condition for perpendicularity of two lines? In analytical geometry, one important condition is that perpendicularity of two lines with respect to slopes. About that condition now we'll discuss. Sixth, the condition for perpendicularity of perpendicularity of two lines is given by the product of slopes of given two lines is equal to -1. That is, we can take m1 into m2 is equal to -1. m1 into m1 is equal to -1. When you are seeing perpendicular to lines like this, it is the L1 Otherwise, you can take is the L1 and is the L2. And these two are perpendiculars. And the slope of M1 is the slope of first line and M2 is the slope of second line. When they are perpendicular to each other means definitely the product of slopes of those two lines is always equal to -1. Wherever in analytical geometry if you can heard about perpendicularity of two lines means definitely you must and should take the product of slopes of given two lines should be always equal to -1. When the product of lines or the product of slopes of given two lines equal to -1 means definitely those two lines are perpendicular to each other. Based on this condition, we can give one condition here, that is M1 into M2, M1 into M2 is equal to -1 if and only if and only if L1 is perpendicular to L2, L1 is perpendicular to L2. Same thing. Left to right what happens? Same thing. Right to left also same thing will happens here. How means the product of slopes equal to -1. The product of slopes of given two lines is equal to -1. Then definitely those two lines are perpendicular to each other. That is L1 is perpendicular to L2. If L1 is perpendicular to L2, then definitely product of slopes of given those lines equal to -1. Like that, one important condition is there to show perpendicularity of two lines with respect to slopes. First one is a parallel condition and second one is a perpendicular condition. First one is you can take any number of parallel lines, 2 lines, 3 lines, 4 lines. You can take any number of parallel lines. Slopes of all the parallel lines are equal. But I told one point in sixth. No, sixth, in case of sixth point, that condition exists for only two lines in xy plane. In two-dimensional geometry, this condition applicable for only two lines. That is the perpendicularity of two lines only here. Next, let us will discuss about another points now. Seven points. The condition for the condition for the condition for the 3 points. The condition for the 3 points A, B and C are said to be collinear or said to be collinear or said to be collinear. A is given by slope of AB is equal to slope of AB is equal to slope of BC. See here, if you can take one line is here, line here, and this take here A point and here B point and here C point. All 3 points lies on the same line here. Already I have given condition for 3 points are collinear with respect to distance also I gave. What is with respect to distance I give formula? Distance of AB plus distance of BC is equal to distance of AC. Even in case of area of triangle also have given condition. What is the area of triangle and condition? The condition for the 3 points A, B and C are said to be collinear is given by area of triangle is equal to 0. Like that we have seen some different conditions to show the given 3 points are collinear. Here also in the slope concept, one important condition is that to show all the three given points are collinear is given by slope of AB is equal to slope of BC. Otherwise we can take slope of AB is equal to slope of AC also we can take. Or and one more condition is slope of AB is equal to slope of AC also. Slope of AB is equal to slope of AC also we can take. Like that conditions are there to show the given 3 points are said to be collinear here. See here. When the will ask show that the given 3 points are collinear like that, we have to find out individually or separately slope of AB and slope of BC. Whether they are equal or not, we have to check about those. If they are equal means easily we can tell about those 3 points A, B and C are collinear points. Otherwise you can check by this condition also. In some problems, in some cases, but we are applying this condition also. That's what about the because of that is only I have given one more condition to find collinear points with respect to slope conditions here. Next we will discuss the last 8 points. Eight points. If a line segment joined with the 2 points, if a line segment joining of the 2 points, joining of the 2 points, capital A, x1 comma y1 and B, x2 comma y2, then the slope of the line segments, is given by m is equal to y2 minus y1 whole dividing by x2 minus x1. If line segment joining of 2 points at a time, we are going to applying this formula. About that means next class onwards I will tell you proof of this formula also, because like we are calling like slope theorem. If line segment joining of 2 points, then the slope of line segment formula is m is equal to y2 minus y1 whole divided by x2 minus x1, like this. X-axis, y-axis, origin, and line segment joining of 2 points here. Here A is x1 comma y1 and here B is x2 comma y2. The angle is made by theta here, like that. If line segment joining of the 2 points x1 y1 and x2 y2, at the time we have to apply this formula m is equal to y2 minus y1 by x2 minus x1. That is the difference of y coordinates divided by difference of x coordinates. Like that we have some important notes we have today. At the same time, next class onwards I'll tell you proof of slope, how we are going to getting a slope formula. That is if line segment joining of 2 points, say ax1 y1 and bx2 y2, then slope of line segment m is equal to y2 minus y1 by x2 minus x1. For that I'll give you proof also. Even at the same time, I will give proof for perpendicularity of two lines also. Perpendicularity of two lines means the product of slopes of given two lines should be is always equal to -1. To that also I'll give proof on next class. That's what. Today I have given slope basic concepts and definitions of slope. At the same time, how we are finding the slopes of axis and what are the slopes of lines which are parallel to coordinate axis. At the same time, I have given conditions to parallel lines and conditions to perpendicular lines. At the same time, the last formula is if line segment joining of 2 points, then formula for slope also have given. And next class onwards, I'll give you proof for slope formula, at the same time perpendicular of two lines also. Thank you very much.